Hello students and friends, most welcome to Dr. Acharya Academy. Today I am going to discuss the Charles law, which is the part of the gas laws in the unit number 5 of the CBSE Chemistry class 11 syllabus. Today's class number is 099. Charles law, which describes the relationship between temperature and volume of gas. Then both Charles and Gay-Lussac performed several experiments on gas independently to improve upon hot air balloon technology. So during their investigation, it was found that for a fixed mass of a gas at constant pressure, the volume of a gas increase on increasing temperature and decrease on cooling. Based on their experiments, they calculate quantitatively that how the volumes of gas increased or decreased as per the raising or cooling the temperature of the gas, and they found that the volume of a gas increased by 1 by 273.15. This fraction increases by this fraction of the original volume of the gas at 0 degrees centigrade. We have to mention this temperature always 0 degrees centigrade in this case. And thus, if volumes of the gas at 0 degrees centigrade and at T degrees centigrade are V0 and Vt respectively, that means when the gas at 0 degrees centigrade, then volume will denote as V0, capital V subscript 0. And when the gas is T degrees centigrade, then volume we denote Vt. In this case, the equation will be Vt is equal to V0 plus T by 273.15 will multiplied by V0. So after simplification, this is the equation Vt is equal to V0, and within first bracket 1 plus T by 273.15. Roughly we can write at the 273 for the convenience of describing it, but the accurate number is the 273.15. So we can define a new scale of temperature because one value has come to 73.15. So at T degrees centigrade, this small t, small letter t, we denote for the centigrade scale, T degrees centigrade. Now it will convert in the new scale, that means new scale temperature will denote as the capital letter T, and capital letter T is equal to 273.15 plus small t. This small letter t denote the temperature in centigrade scale. So at 0 degree centigrade, what will be the capital letter T, our new scale of temperature? Then capital letter T will denote as T0, and in that case, the capital letter T0 is equal to 273.15, because if you see the left side equation, that T, small letter T, is the 0. So this new temperature scale, that means capital letter T is the new scale of temperature. It is called the Kelvin temperature scale, or we can write as the absolute temperature scale. So now the 0 degrees centigrade, which is in Celsius scale, is equal to 273.15 Kelvin. Kelvin always will write the capital letter K, and here you have to remember always it doesn't have left side superscript that degree. That value is not the in centigrade. You can see that capital C, capital letter C, and before that superscript the 0 is there, but here for Kelvin, when you write the unit, then it doesn't have any degree sign. So Kelvin scale of temperature is also called the thermodynamic scale of temperature, and Kelvin scale of temperature is used for all scientific works. So whatever I already told, that roughly will tell 273 the value, and if you add this to the Celsius temperature, then you will get the temperature in Kelvin scale. So it is mentioned there that we can write capital T subscript small t. That means we are converting the Celsius temperature to obtain the absolute temperature. That means that Kelvin scale temperature, capital letter T subscript small letter t will denote like this, and then its value will be the 273.15 plus T. And so in this case T0 means the absolute scale or Kelvin scale temperature at 0 degrees centigrade. In that case, whatever I described previously also, this value is 273.15. So we can obtain a equation. If you see, then from the previous equation, if we add, then Vt is equal to V0 multiplied by Tt by T0. Here right side, if you see, explanation is there. Vt is equal to V0 plus T by 273.15 multiplied by V0. Whatever quantitative calculation we got from the Charles experiment, and then if you calculate this value, you see that this 273.15 plus T, this will convert as the Tt, and down it is the T0. So then left side, if you come the equation, so we can write Vt by V0 is equal to Tt by T0. From the right side detailed calculation, you can clearly understand this. So general equation we can write on the basis of the previous equation just now we described, that V2 by V1 is equal to T2 by T1. When at T1 temperature, the volume is V1, and when at T2 temperature, the volume is V2. And in this case, the V1 by T1, this V1 will go right side above, and then the T2 will come down left side. Then V1 by T1 is equal to V2 by T2. This is the simple equation rearrangement. And so in general, you can tell that V by T is equal to constant, and whose value we consider about the K2, small letter K subscript 2. During the describing the Boyle's law, whatever constant is there, then we consider as the K1, in this case Charles' law, with all the gas laws, in this case that constant is denoted as K2. So V is equal to K2T. Now always T in at which scale? Yes, Kelvin scale, or Kelvin scale also called the absolute scale. So now we'll see the value of the constant K, how to determine, and this constant K2 determined by the pressure of the gas and the amount of the gas and the units in which the volume V is expressed, because K2 is equal to V by T. So it depends on the V and depends on the T, and T also dependent by the pressure of the gas, and amount obviously it should be there, because the amount of the gas, number of moles will change of the gas, then accordingly K2 value also will change. So this mathematical expression V is equal to K2T, this is for the Charles' law, and Charles' law says that at the pressure remaining constant, here always we mention the pressure remaining constant and mass also remaining constant, that means that a fixed mass in a volume is directly proportional to the temperature when temperature is in absolute scale or Kelvin scale. So this is the final derivation from the Charles' law. We have to remember this. And now, right side you see one graph is there. As I told that pressure denoted by P, it will remain constant, and amount of the gas also always should be fixed. In this case, at different pressure, we can get the different straight line. When you plot the volume of the gas against the temperature of the gas, and in this case the temperature is a degree centigrade. Want to show that when all straight lines down, it meets in the single point, the x-axis. X-axis means temperature in degree centigrade, and here the value is the minus 273.15. This is, we have to remember, this is the experimental value, and on that basis Charles' law, whatever the derivation has come, and that number has come from the experiment, this 273.15. So this slope of lines obtained at different pressure, here is P1, P2, P3, P4, and P1 is the very less, and commodity is increasing order P2, P3, and P4. When the pressure is increased, then you see the slope of this line also going down. So we can tell the slope of lines from this graph obtained at different pressure are different, but at zero volume. When this point, if you count, then the volume is zero. because volume is here only, 0 volume. Here you see that here is 0, this means the 0. Y-axis which is the volume, this is the 0. But at 0 volume, all the lines meet at temperature axis at minus 273.15 degrees centigrade. Whatever I already discussed. Yes. So, what is the observation from this graph? Charles interpret that if we put the value of T in equation, we can see that the volume of the gas at minus 273.15 degrees centigrade will be 0. This means that in that temperature, that gas will not exist. And if you see the equation, it described nicely, because when you are considering this T is the minus 273.15, then this value is left side is the minus 1, that means 1 minus 1, that means it is the 0, and it multiplied by V0 means 0. That means the Vt at that particular temperature, minus 273.15 degrees centigrade, is the volume is the 0. The volume of the 0 means that gas will not exist at that particular temperature. So, because gas is composed of some molecules of some materials, so this gas get liquefied before the temperature is reached. That means when this temperature will reach minus 273.15 degrees Celsius, before that only gas is converted to the liquid form. The lowest hypothetical or imaginary temperature, if we consider further down the temperature at which the gas is supposed to occupy 0 volume, this is called the absolute 0. So all gas obey Charles' law at very low pressure and high temperature, because it is the ideal gas laws. So ideal gas laws will have some criteria, and in this case the Charles' law will work at very low pressures and high temperatures. So now we'll go one problem, quantitative problem based on the Charles' law. On a ship sailing in Pacific Ocean where temperature is 23.4 degrees centigrade, a balloon is filled with 2-liter air. So what will be the volume of the balloon when the ship reached Indian Ocean where temperature is 26.1 degrees centigrade? So this problem is based on the temperature versus volume. So we can solve this problem by Charles' laws. What is the Charles' laws? Charles' laws is the volume is proportional to temperature when temperature is in absolute scale or Kelvin scale. We have to remember, because always you have to convert this centigrade temperature in the absolute scale by adding 273.15. Now you see that in the first case, in the Pacific Ocean, V1 is equal to 2 liter, what I mentioned in the problem, and T1 after converting from the centigrade to the absolute scale K, the value is 296.4 Kelvin. And in the second case, when it comes in the Indian Ocean, what I mentioned there, in that case temperature is mentioned. So T2 is equal to that 26.1 degree centigrade, and after converting to the Kelvin scale, this is the 299.1 Kelvin scale. So to remember, the Kelvin scale and absolute scale is two different names for same temperature scale, which is denoted by the capital letter K, and capital letter K doesn't have any degree sign. We have to remember this. Should be cautious about this. And from the Charles law, already what I described, that V1 by T1 is equal to V2 by T2. Then now it is unknown is the V2. So V2 is equal to V1 T2 by T1. Then all value you put, because you know from the problem V1, T2 and T1's value. So if you put this thing, then V2 is equal to, after our calculation, it will be 2.018 liter, and that is your answer, the problem. So I hope that you understand the Charles law and what is the different temperature scale, that means Kelvin scale or absolute scale. And on the basis of the Charles law, one equation is derived when is the volume is proportional to the temperature, when temperature is in absolute scale. And one problem based on this we solve in this class. Thank you so much for watching this class.